Good morning, good afternoon. We are going to be talking about 4.7 linear and nonlinear functions. There we go. Linear and nonlinear functions, 4.7. Alright, first, nonlinear functions are functions that do not have a constant rate of change. Graphs are not straight lines. Nonlinear, not straight. That rate of change, we need to find the rate of change, finding the change in the y over the change of the x. Okay, remember linear functions have a constant rate of change. So constant means the same. Each time it's the same. Or it reduces down. If it's a ratio, it reduces down to the same. Increasing function is when a function whose y and x are both increasing. Okay, both the x and the y are increasing, and then a decreasing would be one is going up and one is going down, or the y value decreases and the x increases. So we're going to do a few examples. The next is determining whether the table represents a linear or nonlinear function, and then explain. Well, the difference between linear and nonlinear is one is constant rate of change and one is not a constant rate of change. So that's exactly what we have to find. We are going to be finding the rate of change here from 50 to 35, 35 to 20, 20 to 55. Whoops. And each time you are subtracting 15. So 50 minus 15 will get me 35. I can check that math on a calculator. So I'm subtracting 15 each time. 2 to 4, 4 to 6, 6 to 8. I'm adding 2 each time. Just adding 2 or going up 2. So, is it linear or nonlinear? It's going to be linear because it has a constant rate of change. And then if it's decreasing or increasing, remember, one is going down, one's going up, so it's going to be a decreasing. If these are different, one's positive and one's negative, it's going to be a decreasing rate of change. Decreasing. Okay, so let's go over to here. So here, the change from 1 to 16, I'm adding 15. 16 to 49, well, in your head, I can't do that as quickly, so what I'm going to do is I'm going to take 49 and subtract 16. So 9, 16, 5, 30, whoa, wrong math, 33, sorry. So I'm adding 33 there. So right away, I see one's 15, one's 33, and over here, I'm adding 3, and 4 to 7 I'm adding 3. So if you notice, one side is 3. They're both 3s. One side is different, so you can stop right there. Non-linear. Okay, it does not have does not have a constant rate of change. ROC, rate of change. But now is it increasing? It's not constant. It does have a rate of change, but is it increasing or decreasing? Well, they're both positive. They're both adding. Both sides are adding, so it's going to be an increasing. Okay. Let's go on to the next problem. Find the difference here. 20 to 16, I'm going to subtract 4. 16 to 12, I subtract 4. And 12 to 8, I subtract 4. If the top change here is the same, then it's going to be a constant rate of change. So 0 to 5, I'm adding 5. 5 to 10, 5. So if I notice, I have the same number up here and the same number down here. So it's a constant rate of change. We would say that the rate of change would be negative 4 over 5. Now, I want to say that it's linear. Oh, linear, yeah. Constant, because constant rate of change. And then is it increasing or decreasing? If I notice, one is minus or a negative and one is positive. So my rate of change is no, one's decreasing, sorry. It's decreasing because one is negative, one is positive. Okay? Here, 0 to 2, we're adding 2. Each time we're going to be adding 2. 2, 4, 6. Okay, here, 0 to 2, we're adding 2. 2 to 8, we're adding 6. And 8 to 18, we're adding 10. So that is not the same constant change each time. So it's going to be non-linear, not constant. But they're both positive numbers, so it's going to be increasing. Okay. Our next problem. Tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? So we're just going to be looking for our rate of change. Again, 5 to 10, I'm changing by 5. 10 to 15, 5. 1. I'm adding 1 each time to the number of tickets sold. So it is going to be linear. It has a constant rate of change. Okay. Next, we have 2 problems left. Alright, a square has a side length of s inches. The area of the square is a function of the side length. Does the situation represent a linear or nonlinear function? So what we're going to do is we are going to create an equation. So the area is going to be our y of the square is a function of the side length. So the side length is we're going to say that's s. So that would be the area is equal to, it's going to be the side squared. So whatever the area is, it's going to be the side squared. So if if the side is 2, all of the sides are 2, correct? So then 2 squared would be the area. So and that's going to work for any square. If the square is 3, all 3, so you could do 3 times 3, right, to find the area of this. But because it's because it's a square, these are always going to be the same. So it's just going to be the side length multiplied by itself, and that's what this 2 means here. It's just multiplying s by itself. So 3 times 3 would be the area there. So because that, we can make a table here. So the side length and the area. So if the side length is 0, the area would be 0, right? Side length of 1. And we're going to do some math here. So side length, 0 squared, 0. 1 squared, we're putting in the side length of 1 into for s, we're substituting it in, and then we're multiplying it by itself. That's what the squared is. So 1 times 1 is 1. We're going to put 2 in here. So 2 squared is 4. 3 squared is 9. And 4, we'll stop at 4. 4 squared is 16. Okay, so we want to find that difference here. And that's all 1. You're adding the 1 to the side each time. Okay, here we're adding 1. Here we're adding 3, 5, and 9. So we have a difference here. So it's going to be non-linear. Okay, it does not have a constant rate of change. Okay, so Our last problem, a square has a side length of s inches. The perimeter of the square is a function of the side lengths. So does the situation represent a linear or nonlinear function? So the perimeter is going to be all of your side lengths of your square added up. So if this is s, it's just representing the side length. If this is s, this is also going to be s, because squares are always the same. So these are all going to be s's. Well, instead of doing s plus s plus s plus s, I could multiply whatever your s is by 4. So to find the perimeter of a square, it would be 4s. Well, and that's going to be your perimeter. So again, we're going to create a table. I could have also written this like this. P equals 4s. Okay, so our side length, we're going to multiply it by 4, and we're going to get our perimeter. So we're going to go ahead and do 0, 1, 2, 3, and 4 again. So 4 times 0, 4 times 1, 4 times 2, 4 times 3, and 4 times 4. So we have 0, 4, 8, 12, and 16. We're going to find the rate of change. And the rate of change, we're adding 4 each time here. Okay, so this is linear because it's a constant rate of change. Okay. Your assignment is page 331, 1 through 11, odd, 17 through 21, odd.